In this video, my attempt is to bridge the gap between a visual idea of an atom from the middle school type models to a more abstract notion of what an atom is to be held in your head. So you should have a mental idea of what's going on with the atoms while we're doing chemistry this year. So let's start with a middle school concept. In a middle school concept, you would have some nucleus with a number of neutrons, let's say there's 5 there, and some number of protons, let's say there's 5 there, and that would make the atomic number of this structure that we're going to draw a 5. In the case of atoms, that 5th atom is boron, which you can look up in your periodic table. And for a middle school concept, what we're going to have is electron cloud, and that cloud's first energy level is going to have 2 electrons in it, and then you're going to have another electron cloud, and that second electron cloud is going to have 3 electrons in it. And in this way, your middle school concept says you have 5 protons. That means the atomic number of this atom is 5. And you have 5 electrons because atom is neutral. It's balanced between its proton number and its electron number. And they're both 5. In this case, that's known as the atomic number. Now let's contrast this with more of a high school concept. In a high school concept, you're not going to have an energy level that contains all of your electrons in one, just kind of like a ring. What you're going to have is what we call suborbitals. Each energy level, in this case the second one, is going to be actually made up of different shaped clouds of electrons. Let's see what that might look like. When we've got the nucleus, we're going to start the same as we did in the middle school concept. This time let's go ahead and add in 10, there's 5, 10 neutrons, 10 protons. And we're going to start building electrons to match. There's 10 is our atomic number. When we start with electrons, we're going to put them in a cloud. This cloud is a sphere. We call this an S-shaped cloud. And we're going to put 2 electrons in there, very much like in the middle school concept. We're going to start a second cloud. We call these orbitals, so our second orbital. And this cloud, also having 2 electrons, this cloud is actually only one suborbital, because when we start adding more electrons, we're going to make a different shaped orbital. You'll notice I'm trying to go out to the second layer with this shape to show that it's a second energy level, that it's still the orbital, the second orbital, but the shape is indicating that it's a different suborbital. And I'm drawing X axis suborbital. I'm drawing a Y axis suborbital. And then there's a third suborbital. Let's call this the Z. This one's coming out at you from the screen, and this one's going away from us past the screen to the back of the computer screen. These would actually hold first 1 electron on the X axis, then a second electron on the Y axis, then a third electron on the Z axis, and then since we need more, because this only gets us to 7 electrons total, since we add more, We're going to add a second one on the X, a second one on the Y, a second one on the Z, for a total of 6 electrons on this orbital. I'm going to emphasize here that first orbital had 2 electrons. This second orbital has, that's actually going to total 8 electrons. 8 electrons. 2 electrons in the sphere shape and 6 electrons in the P-shaped. So if we add those electrons up, then that'll total 10 electrons altogether. 2 in this first layer, we call the first orbital, and 2 in the second orbital. I want you to again understand that that second orbital is made up of what I drew here in red, sphere shape, and then what I drew here in blue, dumbbell shaped orbitals. You should have a diagram that we've been working with in your journal, and it tells you how to keep track as you're building up an atom of when you should add sphere shaped and when you should add dumbbell shaped. We also will have more practice going past the sphere, which we call S, past the dumbbell shape, which we call P, and we'll be practicing with double dumbbell, we call that D, and with other various shapes a little bit. We call those F. You should have a diagram that looks very much like that in your notes, and I'm going to show you how that looks just real quick. Just delete all this stuff, and I'll show you what that looks like in your journal. Just going to delete all of this. And in our journal we drew, or we colored in a small copy of the periodic table, and it had this we call the S block that was in red. Way over here across from the S block we had the P block, and we colored that in blue. We also saw that helium, which is over here, is red for the purposes of sp DNF orbitals. You can just imagine that helium is in that little gap right there in the S block. We also had we had in our diagram, and we're going to be practicing with it, D block, and then there's also, I hope you colored this little area here that expands out to 2 rows. That's F block. So going again from middle school concept to high school concept, in middle school you just had rings that made up the clouds. Each energy level was a ring built up from the nucleus out. In the high school we're still building those same energy levels, but within each ring there are different shaped clouds, which we call suborbitals, and each ring we can call those orbitals. And we get this idea of orbits left over from Niels Bohr's model of the atom, which was like planets going around the sun. Of course, now we know that these are actually just clouds of probability and energy levels. And so please keep up with this. Don't give up. Develop some kind of abstract idea about what an atom looks like, because you will need that so that you can visualize what's happening in chemical reactions.